high. Let's continue. So our top formula works fine. Next, um, next, simulate option data. Okay, simulate option data. So first, let me say, let's give seed, np random seed, and then 42. Okay, so that we get consistent result. And then let's say size draws. For size, let's say it is just, obviously it is too small, but I will increase it later. So data set. Okay. So number of simulation. Okay. And then we want to simulate those values. So let me copy. Okay. And then, okay, SK, they are all I have to simulate. Okay, so for S, it is a stock price. So let me, stock price is not negative, so random. And then uniform distribution, rand, and then draw. So it will generate 1000 random number from 0 to 1. And then I want to multiply 100. Then I have a stock price is a random number from 0 to 100. Okay. And then for strike price, so strike price, so NP random number, and then something more reasonable, maybe some integer number here. Let me generate some integer number, landing integer. So integer number between 50 and then 1, so high 150 number, and then size draws, and then yes, draws, and then yes, and then let me, I think this is fine. Okay, but since if exercise price is too far from stock price, then they are not so informative. Therefore, let me multiply by, because I multiply 100 over here, right? Scale down 0.01 and then multiply S again. Okay, stock price, and then this one. This one is time to maturity, so it is definitely not necessarily integer number, but let me make an integer number. So let's say some integer number, maybe from 10 to maybe 300 number of drawers, and then let's multiply by 0.01. Okay, So the time to maturity is some reasonable number. Okay. And then R is interest rate. R is interest rate. So I think in this case, interest rate, of course, now the interest rate can be negative, but let me consider only positive interest rate. And then let's divide by, so maybe 10% is possible. So in this case, let me divide by 10, 0, 1. And the dividend, same. Okay, this one. And then sigma is volatility. Volatility is always positive. So sigma is same. MP random draws. Possibly very high volatility. And then call option is either option type. Okay, option type. Sigma. So option type. Option type. Option type is either 0 or 1. So I have to choose random choice and then either 0 to 1. Okay. How many? 1000. Okay. Okay, fine. So I have a bunch of input and then of course I have to generate option price. Right. So option price is, let's say, and then let me simulate option prices, and then it is a simulation. Yeah, simulate input for option data, and then here simulate option price, and then let's save option price at OPT price, and then initially it is empty, of course. Oops, empty, and then of course I have to calculate option price. So P is European option, and then I have inputs over here. Input over here, and then of course core option type is the op type. Okay, option type. Okay, right, and then because they are all yes numbers, so let me put I, so I have to simulate one by one. Yes, one by one. Let's say suppose I equal 1, then P, okay, it seems fine. Print P. Okay, it simulates option price. Okay, and then of course for I in range. Okay, range draws. And then I can simulate option price like this. So this is not necessary. Oops, necessary option price. And then I want to append this one. I want to collect option price. Okay, then I collect option price like this. And then, of course, now we have only 1,000, but whenever I have large numbers, and it is good idea to see whether we are simulating correctly. So if I reaches 5,000, which is 5,000, let me print 5,000, print, and then generated how many options, and the format I. Okay, sorry. Okay, generate 0 because it didn't reach 1,000. Okay, so that's fine. Okay, that divided by 5,000. Okay, and then of course we have to give names for the data. So for option prices, okay, for data, let's create data frame. Of course, in order to create data frame, we have to import here. Import pandas as PD. And then here, create a data frame such that let's name options. And then PD, and then data frame. And then we want to collect input and output, right? So, and then, okay, input and output. So for S, I plug S. And then for K, I put K. I need a comma. And then another third one is T, time to maturity. For T, and then we have R. And then of course R, risk-free rate. And then we need D. And then T. And then sigma. And then sigma implies, volatility. Sigma. And then option type. Okay, type. Whether it is call or put, it is the OPT type, option type. And then finally, we need option price. Price is OPT price. Done. Oh, Okay, and then let me print options head. Okay, so yes, so strike price. So it is this per price, strike price, time to maturity, interest rate, dividend, and then sigma type and option price, corresponding option price. And then let me say print options. Okay, 1008 input. So I have simulated 1000 number of scenarios, and then 1, 2, 3, 4, 5, 6, 7, 8, 8. Okay, so we simulated data for option price.